Hi, this is Justin Aquilante, ESA Sales Director, here today with Owen Shalens, Solar and Storage Product Director, and Charu Mahendel, Controls and Software's Product Director for GE's Renewable Hybrids business. Welcome. Owen, Charu, here's a question for both of you. There's a great deal of interest for storage in the energy industry. What would you say are the key technology innovations we see in that space today?
Thank you for the question. I guess I would first start by recognizing that there are many interesting battery chemistry efforts that are underway that are potentially going to disrupt and change the industry in ways we can't imagine. And while that may seem to be a bit of an obvious statement, it truly can be difficult to understand how much an industry like this can move over the next 10 years. However, since the battery scope is really not part of our OEM offering, our goal is to remain flexible and compatible with all the types of batteries. I'll focus mostly the answer on the scope beyond the battery itself. So for example, if we look at the scope from the battery terminals to the point of interconnect with the grid, there are many opportunities to innovate through systems integration, leveraging power electronics, power systems, and grid integration expertise. These innovations will help us better manage aspects of battery short circuit risks and overall safety. We'll also be able to optimize inverter design to kind of minimize the footprint required for deployment, and also enable a total overall lower installed cost through simplification of the deployment of the battery energy storage system, inverter, and the EBOP around it. So beyond that, the opportunity to innovate extends and even further is amplified when you consider the multiple renewable energy sources that could be behind one point of common coupling, right? Such as wind, storage, solar, all collaborating as effectively a hybrid power plant. So therefore, I would effectively summarize that the innovation outside of what is taking space in the battery world lies in systems engineering and controls, and effectively that at the intersection with power systems and the grid integration technologies that enable it.
So in addition to what Owen said, I'll highlight maybe not technology innovation, but there's a lot of innovation going in terms of how these energy storage assets are being utilized by the grid, right? So you look at all the next generation of grid services that are being defined in the UK, or systems that are looking for inertia or grid farming capabilities in the future, right? So there's a lot of innovation in that area. There's also innovation in terms of how energy storage and hybrid assets are paid for, right? So you have the Wieder stack in New York, or hybrid auctions in India, or South Africa recently had a risk mitigation IPP program, right? Hybrids are participating in all of these, providing different values, right? So when you see so much innovation around how people want to use hybrids, you have to offer a solution that is also flexible to serve all these diverse needs and use cases, right? So driving flexibility in the solution is an area we work on, and it's reflecting in how we have named our hardware and software platforms as well.
Again, I have a question for both of you to answer. We hear a lot about the price of batteries. What would you say the levers are to drive its costs down?
So I think while much of the cost today lies with the battery itself, and as previously mentioned, the innovation and scale that will develop over the next decade will certainly drive that cost down. However, today, we do see tremendous opportunity to optimize the cost through systems engineering and configuration. So we're focusing on extracting maximum stored energy from those batteries through our rack-level DC-DC architecture. We're also maximizing utilization and configuration of the inverter itself to minimize the number of inverters needed and the quantity overall on a project. And lastly, offering solutions such as stacked energy storage systems, for those very challenging footprints. Those are all activities that can help bring the cost down. In addition, we're focused on technologies to further reduce our OpEx cost, as well as increase items like, or parameters like round-trip efficiency, by intelligently managing our auxiliary consumption as well as thermal management systems. Those, in addition to many others that help drive the cost down at the system level, are opportunities that we see today.
Yeah, so just pulling a thread that Owen mentioned here, right? There's cost reductions that will come from better controls. And there's three elements to a control system, right? You have to see what's happening, which is your sensing that you do as part of your control system. You have the brain of the controls, which is your sophisticated algorithms. And then you have to act on that, So it needs good actuators, right, to actually take some action and change how the system behaves. And all of this is happening, the seeing and the thinking and acting is happening at a very fast rate. You're talking like millisecond sort of responses. But the DC-DC inverter on every string that Owen talked about, right? It's an actuator that we have now that we can use to extract really a lot of capacity out of our battery system that was previously not available. You can manage charging and discharging and degradation and thermals at a string level, really optimize system performance, life cycle cost as well, right? Also allows us the flexibility, again, that word, to easily augment in the future with a better performing and a cheaper battery, right? So all of these things will come together to drive the cost of the system down.
Charu, where are our biggest opportunities to create value for energy storage projects? Does it come from the battery or other solutions like controls and software?
That's a great question. So I don't think it's either or, right? We just talked about how good hardware enables, like having DC-DC, right? That example I used previously enables us to do better controls, right? So that's the hardware piece of it, right? You unlock more value in terms of more capacity. But in terms of hybrids, right, the biggest opportunity is to make renewables firm and dispatchable. So this clearly has value in terms of high returns for our customers. You can stack more services, but has a huge social value, right? It helps you accelerate decarbonization of the electricity generation sector. So as renewables become firmer and more dispatchable, they provide more energy, more capacity, regulation and restoration services. They then displace non-renewable generation assets that are providing these services today. But the challenge now is you have to do all of these things under conditions of variable renewable generation. So how do you optimally choose the right combination of services to offer into the market daily, right? Maximize your daily revenues, understand how the batteries degrade, short-term and long-term. All of this requires sophisticated software solutions. Again, it's not either or, you need both to really decarbonize the grid, I would say.
Owen, at what scale do you think we'll be able to deploy energy storage systems globally?
Yeah, it's a good question. I think in many ways the technology is really ready to go. However, the barriers to growth and global deployment are not always technical, right? In most cases, we face supply chain constraints, regulatory limitations, incentives and market structures. And in many cases, often project financing can be the greatest challenge or hurdle. So if you think beyond that, there's aspects to deployments in different jurisdictions and regions that are associated with product compliance to the local grid code or technical regulations and standards. And those are things we know how to work through. Thankfully, we're an OEM with a global reach, and we've also been in the power industry for over 100 years, which certainly helps. And the addition to having the ability to provide financing is all part of what we see as a holistic product offering. So as the market develops, as capacity increases, we'll see that those are the enablers to have systems deployed globally.
Charu, do you think that sophisticated control systems will become necessary now for hybrid systems integrated with energy storage?
I think it's absolutely necessary if you want to maximize the value of hybrid systems, right? We just talked about how sophisticated software is needed to make hybrids more dispatchable, create higher value for the system and for our customers. But we also think hybrid assets are more than just a sum of its parts, right? If the only thing you were looking for is like functionally tie a few different assets together, then you don't need to be highly sophisticated. But we don't think that's good enough if you're looking to displace non-renewable generation. So here's what I'm talking about, right? Generation assets have their strengths, and energy storage has its strengths. It's an extremely responsive asset, and they're very complementary. So to create a true hybrid, you have to understand how the generation asset can really run optimally, what its operability and safety constraints are, right? And then how do you effectively share services between generation assets and storage assets? And what this allows you to do is it actually allows you to unlock the capabilities of the generation assets. So till today, these generation assets had to do things that they were not really designed to do optimally. So for example, we have built a few gas turbine energy storage hybrids so far. And what we see is we are able to run the gas turbine better. It has higher overall efficiency, has more than 70% lower stacked emissions, 80% lower water usage, a lower number of starts. I can just go list the benefits, right? But it all came from the capability that the energy storage asset and our controls extracted out of that asset. And this is really personally exciting for me. We have an amazing team with experience in wind, in solar, and energy storage, in gas turbines, in power systems, and digital technologies, right? And we are in this business working together to create value through that domain knowledge and controls. So just to recap, right? We talked about what our customers are looking for. It's just more flexibility in use cases globally, in durations, the ability to adapt to changing market structures and incentives, and then the ability to also create higher system value, right? By being dispatchable. So I would say sophisticated controls and software are absolutely necessary. You can't do it without, you can't provide the flexibility and dispatchability without it.
Charu, Owen, thank you for your time today. We learned a great deal in this discussion. I jotted a few notes down. A large opportunity to innovate and increase the value and scalability of battery energy storage systems is enabled through a combination of a flexible product platform that fully utilizes the capabilities of deployed hardware resources and sophisticated controls to enable higher levels of dispatchable, renewable hybrid energy resources on the grid. It was a great interview. I look forward to talking to you both again in the near future.
Thank you.
Thank you for having us.